Locking is the price we have to pay in SQL Server to prevent concurrency problems. We really don't want concurrency problems, so we pay that price, but it's still a price, and we don't like to pay. Microsoft knows that. So they created two new features in SQL Server 2025, combined marketed as optimized locking to help alleviate the pain of locking. In this video I'm going to talk about one of those two features, transaction ID locking. This feature tries to help us with the problems that we can have if we have large modifications in our database. By default, SQL Server will always lock data at the row level. That's good, because it keeps concurrency as high as possible. But it comes at a price. Nothing is ever for free, everything comes at a price. Here, the price is if you modify a large number of rows, you get a large number of locks. Each of those locks takes some resources, not much. But if you multiply that with a high number of locks, then it becomes a significant resource usage, and this is taken out of the buffer pool that you really want to save to get as much data in logical reads instead of physical reads. Now there are some internal thresholds for lock escalation. If there's more than 5,000 locks on a single table, or if the total number of locks across the entire system has eaten more than 24% of your buffer pool memory, then SQL Server will automatically employ lock escalation, and then all locks will affect the entire table. Hooray! We have all our memory back, but our concurrency is now down the drain. Let's jump into a demo and see how that worked before SQL Server 2025. So I'm going to create the sample table, and as you see, it's fairly simple, nothing special here. I have to wait until this has completed, and then I can jump into the demo. Now, as you see here, I'm going to set the optimized locking feature to off. I first want to demonstrate how things worked before this new feature. So I've switched it off. And I have a statement here, an update statement within a transaction that is not committed. So the 101 rows are now modified, but there's we haven't committed or rolled back the transaction yet, so we are keeping locks on those tables. And you see it is a large number of locks. We have a database lock, that's a shared lock, that sits not in a way that is just to make sure nobody drops the database while we're querying it. But then you have a whole number of exclusive key locks. Those are here to protect concurrent access. And then we have some IX locks that make sure that we can escalate to a higher level if needed, but they do not block other access. And you see, just 101 rows, we already have 309 locks times that approximately 100 bytes of memory. Now, does this work well? Yeah, it works quite well. So let's do this in another connection. So someone else is trying to read data. And if they read data that we didn't update, then it works all fine. This row is not blocked. So we can read that data. But the row with a is equals to 50 will not come back. This select is now waiting until the other transaction releases its locks. And normally transactions would be fairly short, so that wouldn't take as long as it does now. But I deliberately left this transaction open for the demo. And let's see, this is SPIT 64. I'm going to need that value because I want to look at the locks held by this blocked session. And you see here the number of locks is quite low, but one of them has status wait, and that is the key lock. And I want a shared lock, but there is already a competing exclusive lock on that same key, so we have to wait until the update statement is committed or rolled back. And once I do that, you will see that the select finishes and we are good. Now this worked, but as you saw, it were a lot of locks. On a very busy production server, that memory out of the buffer pool is a shame. But like I said, we need to pay that price. Now, if I don't affect 101 rows, but over 90,000 rows, then we don't get hundreds of thousands of logs. No, we get just 24 object logs. Why 24? Why not 1? That is because my laptop has more than 16 CPUs, and at that point a feature called partition level locking kicks in. So basically there's 1 log for each of my 24 logical CPUs. Just a technicality, not really relevant. In effect, the effect is that the entire table is blocked. So now, even though we still didn't modify this row, I still can't read it. Concurrency has been severely affected. I'm trying to read a row that was not updated, but because we escalated to row level logs, it is still being blocked, and I only get my data back when the update has completed. So, with or without log escalation, we had to pay a price. And that is where transaction ID locking comes in. Now, transaction ID locking requires that accelerated database recovery is turned on. And the reason for this is that accelerated database recovery enables the persistent version store. So let's take a step back and talk about the version store. The version store was introduced in SQL Server 2005 already, a long time ago. What it does is when a row is changed, we don't just change the row. We actually store a copy of the row before the change, so the old version in tempdb, and then we modify the row in the user database. Of course, because we store this in tempdb, it's all lost on restart. Another thing we do is we need to tie those old and new versions of the row together, so there are 14 bytes added to the row for the so-called nest ID. That's a combination of the transaction ID and the statement ID within the transaction. So we know exactly which transaction and which statement within that transaction has updated that row, and a pointer to the previous version. So even if we have multiple old versions in tempdb, they are all connected with those pointers. That is the version store. This was built to support snapshot and read committed snapshot isolation levels. Okay, fair enough. But this is just the version store. The persistent version store was introduced in SQL Server 2022. It is still mostly the same version store. The differences are technical and not really relevant, but the big difference is that now the old row versions are not stored in tempdb, but in the user database, which means that now if you restart SQL Server, you still have those old versions in the database, and this was required so that accelerated database recovery could be built. Now, this video is not about accelerated database recovery, but I needed to talk about that because this persistent version store gives SQL Server access to the transaction ID in the user database. And that is why transaction ID locking requires accelerated database recovery. With transaction ID locking turned on, SQL Server no longer takes individual row logs if you do modifications. It only takes a single transaction ID log. And let's look in the demo how this affects what we just saw. So I'm going to switch optimized locking on, and then when that is done, I'm going to rerun the demo. And let's first make sure that I just modify 101 rows. So without optimized locking, this created several hundred logs. Now there's just 3 logs. A shared database log, an intent exclusive log, like I said, needed for possible upgrades of the logs, but doesn't get in the way of anything. The only exclusive log is an XACT log, the transaction log, and the resource description tells us exactly which transaction logs this table. But even though it is just a transaction log, it isn't and I said logs this table, it basically is a log on the database. So we have a transaction log on the entire database. What this means is that now SQL Server, when it accesses data, it sees, oh, there is a transaction log. If the row I'm trying to read has been modified by the indicated transaction, then I can't read it. This row was not modified by the transaction, so we can read it. This row is modified, and indeed it is blocked. This is, of course, still the price we pay, but this is the price we want to pay. I don't want to see this data. I don't have snapshot isolation turned on, otherwise I would see the old version, but I don't have that. I have read committed isolation level, so this is my desired action. And the problem I had of all those logs taking memory has now been fixed. If I look at, this is now 57, it sometimes changes, that's why I checked. So if I now look at session ID 57, you see that here the log is also a transaction log, but it also indicates which key it tries to read. And if I scroll to the right, you see it is a waiting log. And this waits once more until this transaction is finished, and now we get the data back. So how about when we modify lots of rows? Does that change anything? Let's once more change the update to affect 90,101 rows. And now we will see that we still get only this transaction log plus a whole lot of IX page logs. This surprised me when I saw it. I'm not entirely sure why it's there. It looks like SQL Server is still preparing to escalate to table level logs, but it doesn't actually do it. So we do have the IX logs on the pages. They are not really in the way. They don't affect performance for almost everything you normally do, and the exclusive log is still on the transaction level, which means that we still can read rows that are not affected, while we are of course still blocked on rows that are blocked by the update. So that's how this works. And you saw in the demo what benefits there are. We don't have hundreds or thousands of individual row logs anymore. And if you multiply this with all the transactions running on your system, that will save a lot of memory. Also, you don't have the log escalation anymore, which means that no matter how many rows your modifications affect, they will never escalate to a full table log, and unmodified rows will remain accessible by concurrent access. So these are huge benefits. But they don't come for free. Nothing is ever for free. The first part of the price I already showed that you have to enable accelerated database recovery, which means you are now storing row versions in your user database, which means your user database is larger. That will affect your backup and restores. Of course, the benefit you get is that after that restore, recovery will be way faster. And frankly, if you have a high availability system, then I assume that you have accelerated database recovery on already, because the price you pay is easily gained back by the increased failover time. If you don't have high availability, then turning on accelerated database recovery might be a price you have to think about. But you do get this benefit in return. There's also another additional thing you have to think about, and that is that accessing non-locked rows now takes extra work. Frankly, accessing locked rows also takes extra work, but I don't care that it takes a few milliseconds longer before we start to wait until the lock is released. That row will be available once the lock is released, but the time to access non-locked rows is slightly affected. Without transaction ID locking, SQL Server simply checks the key lock. It's not there. We can read it. With transaction ID locking, SQL Server has to check, is there a transaction ID lock? If yes, is this row locked? And then we have to look at that transaction ID. So there's a very slight overhead before we can access the data. How large is this? Well, let's see by first switching optimized logging off again. So we go back to the situation before we had optimized logging. I'm going to log just 101 rows again. And as you see, we now have all those individual key logs again. Now, if I do a query that counts non-logged rows, let's see how much time this takes. And it takes 21 milliseconds, but the first time is some startup time, so I'll run it again. 11 milliseconds. Let's run it a few more times. 8 milliseconds, 10 milliseconds, 10 milliseconds, 12 milliseconds. So on average, 10 milliseconds. Okay, fair enough. Let's undo this modification and switch back to working with optimized logging. We once more modify the same 101 rows, and now I'm going to run this query again and look at the time it costs. 10 milliseconds, 10 milliseconds, 10 milliseconds, 10 milliseconds. So you see that the difference is not even measurable. Frankly, when I prepared this demo, there was a 1 millisecond difference, which was measurable, but it's still fairly low. So there is some overhead in accessing the rows. It's not a lot. It doesn't really result in a measurable performance difference. The only real price you have to think about before enabling transaction ID logging is, can I afford those 14 extra bytes to the row and those row versions all in the user database to enable this feature? And if you have other reasons to enable accelerated database recovery, then that becomes a non-issue. Now, this feature is not unlimited. It doesn't always work. And the biggest thing I found is it doesn't work if you use one of the higher isolation levels. Let's run the next demo to see this. Repeatable read. Let's see if it works again. And we get all the key logs. So that's what I wanted to show, and I don't know what went wrong before. This is what I wanted to show. All those key logs with repeatable read or with serializable transaction ID logging does not work. And that's because repeatable read and serializable isolation levels also have to hold logs for rows that are read. If you have a repeatable read isolation level and you read a log, then until your transaction has been finished, nobody can modify that log. Otherwise, you can't repeat the read. With serializable, you do the same and then also log gaps in rows that might have returned anything else. So if you do between 1 and 10 and you get only 1, 2 and 7 back, 3 until 10 will still be blocked because we don't want to insert that row. That will break serializable. So those reads cause isolation level, cause locks. They need to be protected. But reads do not update the transaction ID in the row. So we can't protect them with a transaction log. We need a row level log for this protection. So that concludes transaction ID logging. If you liked this video, click the like button, subscribe, leave a comment. If you have questions, leave a comment. Of course, if your servers are slow and you need help fixing it, let me know. I will be happy to help you. In the next video, I plan to talk about the other feature in optimized logging. Until then, bye bye.